Let's think about rational expressions. So a rational expression is something that looks like a polynomial divided by another polynomial. So the word rational is coming from ratio, meaning fraction or division. So let's see examples. So I could have 4x squared plus 2x plus 1 divided by x squared minus 2x plus 1. So in our last video, we discussed what a polynomial was. A polynomial looks like what I have on the top or the bottom here. These are degree 2 polynomials. A rational expression, or a division of two polynomials, is what I see here. Let's do another example or two of rational expressions. I could have 9. 9 is a polynomial. It just has a degree 0. No x's at all, but 9 counts technically as a polynomial. And I could divide by x squared plus 1. There's another rational function. And how about x plus 1 over x minus 4? So here are 3 rational expressions. Now, when you discuss a rational expression, there are certain values you could actually plug in for x, and certain values you cannot plug in for x. So the domain of a rational expression is all numbers except where you would be dividing by 0. So we can't divide by 0, and therefore I don't want to plug in any numbers for x that would cause the division by 0. So the domain is all numbers except where that happens. So let's look at these 3 rational expressions and talk about their domain. So when I think about domain, I just don't want to divide by 0. And if I notice, if I plug in x equals 1 into the bottom, I have a problem. Because if I plug in 1, I get 1 minus 2 plus 1. That's equal to 0. That's the only number that I can plug into the bottom to cause the division by 0. So the domain is all x, but not x equals to 1, excuse me. So I don't want to plug in 1 because that would cause a division by 0. This quantity, x squared plus 1, can never equal 0 for any real number x. So if you plug in any real number, like -5, and you square it, you get a positive. And then if I add 1 to a positive number, I'll never get 0. So the domain is all real numbers. I have no problems here. The domain is all numbers. And then this clearly has a problem when I plug in x equals 4. So the domain is all numbers except x cannot equal 4. We should also mention domains of square root functions. So the domain of a square root expression is all numbers except where we have a negative in the square root. I don't want to worry about complex numbers quite yet, so we're going to just say the domain is where you have no negatives in the square root. So let's do a couple of examples of this. So the domain of the square root of x minus 4 is all values x that are bigger than or equal to 4. Because I don't want to stick in 3 or something smaller than that, because then I'd get a negative and a square root. Another way to denote this is the interval 4 to infinity. So on the number line, you have 0, 4. My domain is any number 4 or bigger. How about the domain of the square root of x plus 1 over the square root of 1 minus x? Well, let's think about this for a second. I can't have any negatives in a square root, and I can't divide by 0. Those are the two main issues when we're discussing domains of expressions. The top, let's see here. So let's draw a number line. 0, 1, negative 1, 2, negative 2. This top function is going to be okay as long as I plug in numbers negative 1 or bigger. So the top is okay on this interval from negative 1 on. And the bottom function is going to be okay as long as I plug in a number x that's smaller than 1. I also don't want to plug in x equals 1, because then I'd be dividing by 0. So the bottom function is okay on this interval. I'd like both the top and the bottom functions to be fine. Therefore, I need the numbers that are common to both of these intervals, or the intersection of these two intervals. Therefore, the correct domain is every number from negative 1 up to but not including positive 1. So maybe writing that down in interval notation, the domain is including negative 1 and not including 1. Okay, this video was designed to introduce rational expressions, so I'd like to finish with one example of simplifying a rational expression. These kinds of expressions you will find if you continue on to calculus. So let's simplify this. Let's do 2 over a plus h. So that's a rational expression. Maybe a is a number and h is my variable. Minus 2 over a, all divided by h. And what I wanted to do in this example was simplify an expression that has fractions within fractions. I personally don't like fractions, and I really don't like fractions within fractions. So I'm going to show you how to simplify this and make it look a little bit nicer. So the first thing I'm going to do is just rewrite this as 1 over h in front times 2 over a plus h minus 2 over a. So I didn't really do anything in this step except take this division by h and put it in front of a parentheses so I could deal with the stuff inside a little bit better. Now, I still have this 1 over h in front, but I'd like to add or subtract two fractions. And the way you do that is by getting a common denominator. So I'm going to multiply the top and the bottom of this first fraction by a. So I'm going to get 2a over a times a plus h. So I multiplied the top and the bottom of this first by a. And I'm going to multiply the top and the bottom of the second fraction by a plus h to get the common denominator. So I'm going to have 2 times a plus h over a times a plus h. So now I indeed have a common denominator. I can combine them. So I'm going to get 2a minus 2 times a. So those cancel. Then I'm going to have a minus 2h left on top. So minus 2h. And on bottom I have a times a plus h. And maybe to finish up the problem, I will cancel the h on top here with the h on bottom and end by writing down -2 over a plus h. Okay, wonderful.